Yeah, I am.
Okay, fine. So let us begin with, from today onwards, we'll do only revision. So because we already
Yeah,
finished all
okay.
the chapters, right?
Yeah, I did.
Okay. Now let us begin with this. The first problem, now we are going to start from chapter 1. A train travels from town A to town B. So town A to town B as shown here. Figure 1 has been drawn to scale. This is a 7-mark question. The distance that what the train travels between A and B is not the same as the displacement of the train. What is the difference between distance and displacement? What is your answer? Is there a difference
Um,
between distance and displacement in reference to this diagram?
yeah. Distance would be the total length of the route that the train took. But displacement is the shortest distance from the starting point to the ending point.
Right. So you should write distance is a total path length and displacement is the shortest distance. Shortest distance. So therefore, if I start from point A, let me label this as, this already is B, so I'll label this as C, this point as D, this point as E, okay, and this is F. So then in that case, I can say distance is nothing but A, C, D, E, F, and B. The whole path that travels along this way, okay, and then until B. So that is your distance, while displacement is nothing but I take a line here, I take a point here, I take the point here, and now draw a straight line like this. This will give me the displacement. So displacement will just be the distance AB. So from this diagram, what can you say? Will the distance be larger or displacement will be larger?
The distance.
Distance would be larger. Okay, fine. Now let us look at the second one. Use figure 1 to determine the displacement of the train in traveling from A to B. From A to B. Okay. Displacement of train. Show how do you obtain your answer. So in your test paper, what happens is you will be getting a bigger figure and they will ask you to calculate the distance using a scale. Okay, so you should have a ruler with you. So here I have taken a ruler here and I am determining what is the distance between these 2 points. So this is my first point here and this is my last point over here. So correspondingly, what is my distance now? What is the displacement now?
It's around 5.6.
5.6 or 5.7 nearly. So therefore, your
Yeah,
displacement will be equal to 5.6 or 5.7 unit
centimeters. Yeah,
centimeter. Sorry?
yeah, centimeters.
It's just centimeter, okay? So show how you obtain the answer. What you need to do is you need to put the scale here and you say that a scale has been put between point A and point B, and then the distance between them is determined by keeping the point A at the origin of the scale, and thereby we see that the marking of the scale corresponding to 5.6 was pointing towards the point B, and as a result of it, we got it. Okay, so this will give you
Yeah,
just giving displacement equal to 5.6 centimeter will not help you out, but you need to write the description also here, right? Okay, now let us go
yeah.
to the next one. There are places on the journey where the train accelerates without changing speed. Explain how can this happen? Where are the places where the train accelerates without changing speed? Explain how this can happen. Yeah.
Mm,
Are there any places where the train accelerates without changing speed?
Um,
What is acceleration?
it's the rate of change of velocity.
Rate of change of velocity, which means velocity divided by time. Am I right? Or you can say
Yeah.
it is delta velocity by time taken. There should be change in velocity. Whenever there is a change in velocity, what do we understand by that? What can change or what should change?
Um, the speed or the direction.
Speed or the direction should change. One of them changes, then definitely you can say that there is an acceleration being observed. Now, where do you
Yeah.
think which locations in the trajectory here describes that there is a change in direction or a change in speed, and hence relates to
Um,
acceleration?
all the places where there's a change in direction, like point C, and D and F.
Yeah, so you have points like C, you have points like D. At F, do you think that there is a change in the acceleration, change in velocity? At E,
Um, E, no,
there is no
there's
change here, but you can observe the same thing in B here, right? Sorry, at F here. At F
yeah,
here. And there are several other locations also you can show across, you can show also at this point also. So therefore, these are the places where there is a change in the direction and hence results into an acceleration. Okay, even if there is no change in velocity. So you should begin writing because it's for 2 marks. You should begin writing saying that if we assume that the train travels with uniform speed throughout its trajectory, throughout its path. Okay, even then, when there is a change in the direction, as seen at points point C, point D, and point F, as shown here, there will be a change in the velocity, which is nothing but the change in direction. The change in direction results a change in acceleration. Okay, so you have to write so
yeah,
much over here when we say about 2 marks. Is this clear?
yeah,
Right. Now let us look at the next one. Figure 2 shows how the velocity of the train changes with time as the train travels along a straight section of the journey. Okay, estimate the distance traveled by the train along the section of journey as shown in figure 2. So now this is the graph which is being given to you. So the graph tells you as a time as a estimate the distance traveled by the train. So what is being given over here? It gives you velocity versus time here. So how do you find what is the distance traveled by the train? What is the distance traveled by the train?
it'll be the area under the curve.
It is the area under the curve. Okay, so how do I find that? He has asked you estimate the distance. What is the difference between estimate and determine?
Um, Estimate means it doesn't have to be precise.
Precise. Think about it. No.
No,
Estimate is
it
an approx which you get. If I ask you
yeah,
to find out, okay, how many hairs are there in your head, you get an estimate there. How many stars are there on the sky in the visible daylight, the night? Okay, you can say it's an estimate. Then determine.
yeah.
Determine is nothing but distance of the school from your home. That is your determine. Okay, find, determine. All this estimate comes there. Yeah. So now, how do you find it over here?
Um,
So you have to
you
get
could
me an
take
approximate value and you have to tell me how you are going to do that.
um, you could draw a line from the point 105. Uh,
Okay. So I will first draw
uh,
a line here. Okay. So this will become
yeah,
one square here. Then I will consider this as a triangle. The whole thing as a triangle until here. Until here. So I will draw one more triangle here like this. Or maybe I'll consider this as a trapezium. I'll consider almost this to be a straight line like this. Okay. So now let me
yeah,
label this. This is point O. This is point A. This is point B. This is point C. And then I'll consider one more here. So this is one more triangle here. This is point D. This is point E. This is point F. And this is point G. And maybe, yeah. So these are the terms that I have. Now, can you tell me how do you find estimate this? Estimate the area here?
you find the area of each of these rough shapes.
Right. So E, F, G, and this is H, and this O. So the total area now will now be equal to O, A, B, H, O. That is the area of this square. And then we have this area. This area, what is this area now? Plus area of H, B, C, G, H plus the last area. So let me call this area again like this. Let me call area like this over here. So maybe I'll include this also. There's one more trapezium. So which is nothing but what is this? HBCGH plus what is the last area? Last area is, let us start from here. F, G, C, D, and E. E and F. Whenever we talk about an area, the beginning point and the ending point should coincide. It should be the same. For example, see, I start from O, end at O. H, it should end at H. Okay, F, it should end at F. Okay, the point
Yeah.
should be the same. So towards it, can you tell me what will be the areas of each one of them? First one,
Um,
AOB, the first one.
it'll be 500.
It will be
Wait,
100
yeah.
multiplied by 5. All of them are in the appropriate units, so this should be 500 plus next area.
Um, it'll be half into 200 into 5 plus 25, which
Into
is
5
30.
plus 25. 5 plus 25 plus
Um,
half into
half into 200 into 25 plus 30.
200 into 25 plus 30. That's it. So tell me what is the answer?
Uh,
This is 500. This is 30 into 2 is 60. 600 divided by 2 is 300. 600, 6,000, right?
uh,
It down 500 plus 25 into 2. 25 plus 5,
plus
30 into 2, 6,000,
three,
which is 3,000.
3,000
Plus this one is
plus, uh,
55 into 100.
so yeah,
5,500.
5,500.
So which should now be equal to 5,000, 8,500,
9,000. Yeah, plus
9,000.
500. Yeah.
9,000 units.
Um, meters.
Meters. It is meters over here. Okay. So this is how you find out the total distance traveled by the train. What will be the displacement?
Um, the displacement. Wait,
Will the displacement also be the same or will it be lesser than this?
um,
Read the question once again. Shows how the velocity of the train changes with time as the train travels along a straight
oh,
section
shit.
of the journey. Which means he is not
Yes.
describing this part. Complete part is not describing here. Okay. So
Yeah.
wherever the train is moving along a straight section, only that one he is now describing here. Right? So therefore, now what is the displacement?
It's the same as the
It is the
distance, so
same as
9,000.
1. Okay. So is the train moving with uniform velocity?
No.
It is not moving with uniform velocity. Why?
Because the speed must be changing, like,
Yeah, the speed is
so.
changing at every instant here. You see, it is now, initially it was 5, then became 10, then became 20, then 30, and so on. So velocity is constantly changing. As a result of this is definitely not moving with uniform velocity. Is it moving with uniform acceleration?
No.
It is not moving with uniform acceleration also, right? Because the velocity is not changing with time regularly. You are not getting a straight line graph, but instead you are getting a curve at different places. See, you get a straight line here, then the curve has been approximated by a straight line, and again you get a curve over here. So you can see here it moves with uniform velocity, here it moves with uniform acceleration, sorry, increasing accelerations, and then there's a retardation here, correct?
Yeah.
Okay, so now all your basics on the first part is clear now, right?
Yeah.
Any doubts on this?
No.
Okay, now let us move on to the next one. Figure 1 shows a golfer using a runaway for testing how far a golf ball travels on the grass. So what he does is, okay, you have a small inclined plane, you take a golf ball over here, and this is a runaway, so you drop it over here, and you just let it go. One end of the runaway is placed on the grass surface, the other end of the runaway is lifted up, and the golf ball is put on the top. So you lift it up as a result of the gravity, and it starts moving like this. The golf ball goes down the runaway and along the glass surface. So it starts moving like this, and then it starts moving in this direction. It starts moving like this. A test was done 3 times with the same golf ball. So one test was done with the same golf ball 3 times. First time you did it, let us say, for example, it stopped here, okay, which was at a distance of 8.5 centimeter. Second time you did it, it was at this distance. Third time it was at this distance. Okay, remember, in all your questions, you are going to use a ruler here, right? And
Yeah.
then the golf ball goes down the runway and along the glass surface. make measurements on figure 2 to complete the table 1. So you need to make the measurements on this. So towards it, what we need here to do this, to answer this problem, what do we need?
Um, we need a ruler.
We need a ruler. Okay, now let us get a ruler here. Now I have put the ruler here. You see, this is exactly avoiding around 8.5 or 8.6 centimeters. Maybe I had to pull this up. So 8.5 centimeters. Now, let us take the same ruler once again and then see what is the distance here. Can you tell me what is the distance now?
It's around 9.6 or 9.7.
9.6 and 9.7 is between them. So which one would you like to take now?
9.7.
9.7. Why 9.7?
It seems to be closer to
No,
9.7.
it can seems to be closer to 9.7, but until unless it is not achieved there or reached there, you should not take 9.7. You should take just as 9.6 only. Okay. So only the previous reading
Okay.
has to be considered. If you have a 2 scale, for example, a 1 year scale, you can accurately determine whether it is 9.65, 9.67, 9.69, and so on. But here you will not be able to determine it. You should just take 9.6 only. Right. Next. Third one. Let us move on to this and go to the next ruler. Now, can you tell me what's the reading here?
Um, it's 10.7, I think.
10.7.
7. Yeah.
7. What are the units for each one of them?
Centimeters.
Centimeters. So remember, I'm not going to put centimeter anywhere over here. I'm just going to retain it just like this. Okay. And then you are going to determine this. Okay. Now, as you see here, every time the distance keeps on changing. Once it is 8.5, 9.6, 10.7. So what do you understand from this? What do you understand from
Um,
this? Any idea what is it you understand from here?
um, it increases by 1.1 centimeter for
True,
each
but
of
why
them.
should it increase? So you are using the same golf ball, I'm using the same angle here. So why should it increase? Can it increase like that? Is it good enough? Is it a good experiment?
Uh,
Are we getting consistent readings?
no.
No, we are not getting consistent readings. Then what could be the reason for this? Though these questions are not asked here, but it is useful when you start asking these questions so that you can understand the complete problem. Yeah. So why do you think that there is an inconsistency here?
Um, because of friction,
Because of
maybe.
friction. Where is the friction?
Yeah.
Where is the friction here?
Uh, the grass.
With the grass. Okay, you mean to say, okay, if there is a friction there, then why should the distance vary?
Uh,
Can we now say that the friction that you mentioned or opposition for the ball, can we say it's opposition to the ball?
yeah.
Okay, opposition to the ball is because of the type of grass that is being grown. Maybe here you have less, more density of the grass, and here you have less dense grass over here. So there's a way for the ball to move across, and here it is much, much lesser. The grasses are much farther away. Can we say that?
Yeah.
Okay, so now this gives you a methodology or an experiment to determine what could be the density of the gas, right? You are not able to determine the density of the grass, but instead you are able to say that the growth of the grass is not seen to be uniform. Can we make that statement?
Yeah.
Right. Okay, that's what you need to do. Okay, now let us move on to the next one. Calculate the mean distance in centimeters between the ball and edge of the runaway. What is the mean distance?
Um, it will be 8.5 plus 9.6 plus 10.7 by 3.
10.7 divided by 3. Use your calculators and get me the answer. What is
It's
the answer now?
9.6.
Yeah,
9.6.
9.6, 9.6 centimeter. Okay, now let us read the next question. Next question says that figure 2 is drawn to scale. 1 centimeter equal to 20 centimeter on the grass. Calculate the mean distance in centimeters when the golf ball travels on the grass. What should I do?
Um, you you have to multiply 9.6 by 20.
So what is the answer? Tell me.
Wait, 192. Wait, 1 second.
192. So you have to multiply 9.6 multiplied by 20 centimeters. What is the answer you're getting?
192 centimeters.
192 centimeters. Okay. So it has really traveled nearly 2 meters on the grass. Okay. Now let us move on to the next one. The distance traveled, the distance the ball travels along the grass surface is used to estimate the speed of the grass surface, speed on the grass surface. The words used to describe the speed of a grass surface is given in table 2. Okay, now let us look at table 2. So table 2 shows you something like this. So which of these terms could be used correctly here? You have got the answer as 192 centimeters. And in how many seconds has it traveled? What time is it traveled now? Speed, okay, the time is not given. So speed is given over here. You need to tell which of these terms would be better to explain it. Which term can be used?
Um,
Can we use a medium fast, medium slow? Which term would be relevant to describe the speed of it? Yeah,
medium.
it could be medium. Medium is 190, right?
Yeah.
Medium fast is 220. Until and unless the ball doesn't achieve this, you cannot say it's medium fast, right?
Yeah.
Now let us start from here. 0 to 130. See, he has given only the outer boundary, 0 to 130. If suppose the ball has achieved a distance of 130 centimeter, then you say it is slow ball. Now, if it is 130 to 160 or 131 to 160, okay, in this interval, you can say it is medium slow, right?
Yeah.
And here it should be 161 to 190, should be medium ball. And if it is 191 to 220, then it should be medium fast. And if it is 221 to 250, then it should be fast.
Yeah.
So what you need to do is you need to construct the intervals initially. Now tell me, so which statement can we use here?
Then it would be medium fast.
Yes, the answer is medium fast over here. So you should be writing this as medium fast. Okay, and then next. Um, use table 2 and your answer in part 2 to describe. Just a minute. Let me move this upwards. Yeah. Describe the speed of the grass. Okay, that's what we have done so far. Yeah. Then next is the shorter the grass, the greater the distance the golf ball will travel. A student uses a runaway on the grass in a local park to measure the distance the golf ball travels. Okay. Suggest 2 variables the student should control. What are the 2 variables the student should control? Now, what does he say? The shorter the grass, the greater the distance the golf ball will travel. A student uses a runaway on the grass in a local park to measure the distance the golf ball will travel. Now, what should we do? Suggest 2 variables the student should control. What are the 2 variables that he should control?
Um, the height of the inclination of the runway.
Which one?
The inclination of the runway.
Inclination of the runway. Okay,
And
good.
the length of the grass.
Length of the grass, or you can say height of the grass.
Yeah.
Height of the grass. These could be, what are these variables called as? Control variables. Okay, because if the
Yeah.
control variable of here, that is the angle here, is made larger, then definitely you will not get a proper result here, right? Okay, she carried out
Yeah.
the test 5 times. Her measurements in centimeters are shown below: 75, 95, and so much. What can she conclude about the length of the grass in the park?
It's uneven. It's
Yeah,
not
there is an
exactly the same in
yeah,
different
there is an
places.
uneven growth of the grass. Right. Next, another student suggested the speed of a grass surface depends on surface other than the grass length. She wants to test a hypothesis that speed depends upon the relative humidity also. Now let us define relative humidity. She suggests that, okay, speed does not depend only on the length of the grass, it also depends upon the humidity. Relative humidity is the percentage of water in the air compared to the maximum amount of water the air can hold. Relative humidity can have values between 1% and 100%. The student obtains the data in the table from the internet. So she searches for this and she gets data from the internet, something like this. Relative humidity expressed as a percentage, 71 percentage. If the humidity is 71 percentage, the mean distance moved by the ball is 180. And if the humidity increases, then the mean distance moved by the ball reduces. Describe the pattern shown in the table. What is the pattern? What type of pattern does it describe?
It shows that the higher the relative humidity, the shorter the distance the golf ball will travel.
Right, higher the relative humidity, shorter the distance traveled.
So it would be inversely proportionate.
Correct. Shorter the distance traveled. If suppose if the relative percentage relative humidity is given as h, then I can say this is proportional to 1 by the distance traveled by the ball in centimeters. Okay, the distance students raise a following hypothesis. The mean distance the whole ball travels is inversely proportional to relative humidity. So you just have the opposite form, that is the other form of it. Use calculations to test a hypothesis and state your conclusion. So does it help you in putting across a conclusion? You have now got the hypothesis. You have to use the data to test your hypothesis. How do you test it?
Um,
How do you test your hypothesis?
you well, you can multiply the
Okay.
relative humidity into the distance
H
and
into
see if all
D.
three give
Yeah.
the
So
same
what should you
answer.
get now as a result of this? H
71 into 180,
71 into 180 will be
12,780.
12,780. And then
79 into 162,
79 into 162. What is the answer you get here?
12,798.
798. And then 87 multiplied by
87 to
147
147.
is equal to
12,789.
12,789. Okay, this is what you get. Can you say that your data that you have generated and the hypothesis that you have laid across, are they going hand in hand?
Um, no, because the values aren't exactly the same, but um, well, they are. Uh, they're
Mhm.
well, yeah, they're approximately the same. So
Yes. They're
it can.
approximately same because you see here the difference is 18 units and here the difference is 89 and 80. There are 9 units over here. So somewhere, okay, 85 or 86 could be the mean over here. So approximately you observe that, okay, so this coming very closer to each other. Okay, the data in table 3 does not allow a conclusion to be made with confidence. Give a reason why. Why can't you arrive at with a given conclusion? Why can't we say that? What is the other factor that I'm missing? It does not allow a conclusion to be made with confidence.
Um,
There's something which is missing here. What is it? You have been given only with the humidity, and the data does not tell you anything about the height of the grass where it was used, right?
Yeah.
Okay, so therefore, if the height of the grass varies, then definitely this data can change. So let us say, for example, he has done this experiment. The internet article has the person who had done this in the internet, what we have taken here. Okay, if we had done it with something like 5 centimeter grass, and now you are going to repeat the same experiment with something like 8 centimeter grass, you may not get the same answer once again, even though these conditions are being considered, right?
Yeah.
So what is missing here? There's something which is missing here. What is missing?
The height. The
The control variables are not being stated properly. Got it?
yeah.
Okay, the control variables had to be stated properly, else you will not be able to say anything here. So that is what is missing here. Okay, now let us move on to the next one. The graph shows the speed of a runner during an indoor 60 meters race. Calculate the acceleration of the runner during the first 4 seconds.
It's
Acceleration. Yeah, what is the definition of acceleration from the graph?
it's it would be speed by time.
Yeah, speed by time. Is it just speed by time or difference in speed by time?
Difference in speed by
Right,
time.
difference in speeds. Can you tell me what is the value now?
It'll be 2.5 meters per second square.
Yeah, so what did you do? You took up something like 10 minus
10
0 divided by 4,
by 4.
which would be 2.5 meter per second square in the first 4 seconds. Okay, in the first 4 seconds. Okay, so you for this, the marks allotted is 3 marks. So you have to write the formula A equal to V minus U divided by T. And then you have to mention clearly that the value of V is equal to 10, U is equal to 0. Okay, and then meters per second unit should be there, T should be equal to 4 seconds. Substituting all this, we get this example, and then finally you come here. Okay, so if you just write, if you just say using a calculator, I have got this, you won't get marks there. You'll get only 1 mark there. Is this clear?
Yeah.
How far does a runner travel during the first 4 seconds? First 4 seconds, what is the distance traveled by the runner?
Um, 20 meters.
Again, you are making the same mistake. I want stepwise.
Yeah. It'll be the distance under the graph. So I'm sorry, the area under the graph.
Yeah, so what you should write? Distance traveled by the runner is equal to area. You call this as O, put this A, this as B, and then you can say area OABO. You have to mention this very clearly. Okay, or area of the triangle. You have to mention this. And after that, this should be equal to half into base into height.
Yeah.
Base is 4 centimeters or 4 seconds. 4 seconds multiplied by height. Height is equal to 10 meter per second. Mention the units along with it. Show the working very clearly. Okay, so this should now be equal to 20 meters. So only then you get 3 marks. Otherwise, you lose marks here. Then at the finish, you
Yeah.
think one of rubber foam slows the rubber runner down at a rate of 25 meter per second square. So here, in this region, let me call this as point C, this is point D, and this is point E. Okay. The runner has a mass of 75 kg. So mass of the person is already given to you. Calculate the average force of the rubber foam on the runner. What is the average force? So how do we find force? What is given here?
The
Acceleration.
acceleration.
Yeah, but he says slowing down.
So
Slows the
it's the
runner down. Okay, he starts from here. So as it is running, as he is running, when he reaches the finishing line here, so there is a rubber foam kept here. And when he steps onto it, then he starts slowing down. And then he stops somewhere over here. Okay, so he is now asking, so if he has to slow down, then definitely rubber foam is now doing something here. It is now trying to oppose him. He is asking you to find out what is his average force, how it has been opposing. So what should I write? How should I do this?
The force is equal to mass into acceleration.
Good.
So it'll be 75 into minus 25.
Excellent. Minus 25. What is the answer for this?
Um, um, minus 1875
Minus 1875 units.
newtons.
Newtons. Okay, good. So this is the force, the opposite force. And then after you write this, you have to say there's a negative sign denotes the force is acting in the opposite direction. In the opposite direction. Okay. Next, the diagram shows a steel ball bearing falling through a tube of oil. So you have a steel ball bearing. Now there's a tube of oil here. You drop it. The forces L and M act on the ball bearing. There is a force L acting here, M acting there. Can you identify what is this L here? What is that force L called as?
Um,
That's what is the question. What causes force L?
um, uh, it's a gravitational
Yes,
force.
it's a gravitational force, or you can say this is the weight of the ball bearing. The weight of the ball bearing, which is equal to m into g. You have to mention so much. The distance time graph represents the motion of the ball bearing as it falls through the oil. So they said distance time graph. That is, as it falls down here, you see there's a distance time graph. Explain in terms of L and M why the ball bearing accelerates at first, but then falls at constant speed. Now, if you identify here, so starting from maybe until this edge, okay, until this edge, until 5 seconds, the particle is seen to be moving with a curved path. And after that, in this region, you observe that this appears to be a straight line. Did you see this, right?
Yeah.
Okay, so this region is an accelerated one. Now he's asking you, this for 3 marks, why is the ball experiencing an acceleration here? And why is it moving this way? What is the reason? Let me see, whenever problems like this comes, you have to label it clearly. Draw a graph, label it clearly like this. Yeah, no. What is the
Um,
answer for this? Why do we get an acceleration from the region O to A, and why the particle moves with uniform velocity in the region A to B?
from O to A, there's an acceleration because of well,
Because,
it's the gravitational acceleration.
okay, so that means there is no gravitational acceleration in this region.
Um, that's when reaches um, it reaches the terminal velocity.
Okay, but terminal velocity comes later on, but before that.
Yeah.
But you need to explain in terms of L and M. See, very clearly the question is asked. In terms of L and M only, you have to express. I don't want terminal velocity here. Terminal velocity is this one, which you are referring here. Your output, your outcome of your question or your answer should be VT, but not now. But before that.
Um,
So now you should say that. Do you have an answer or shall I explain?
I'm not sure.
You're not sure. Okay, fine. So when we say that there is an acceleration, this is not deceleration, it's an acceleration, which means this force is larger than the capital M force. Agreed?
Yeah.
The total force is in the downward direction. So in the region starting from O to A, mg force is larger than the buoyancy force, which is m here. So m represents the buoyancy force, buoyant force. Okay, so here in this region, L is greater than m, and as a result of it, there is an acceleration. Okay, this will give you 1 mark. Then in the region A to B, in the region A to B, we can say that between A to B, the L is equal to M. When L is equal to M, you can now say net force is equal to 0. This will give you one more mark. And lastly, you can say, hence, since the value of L is greater than value of M, or L is greater than M, the particle is constantly accelerated as it reaches a certain value. And beyond a certain value, okay, after a point A on the tube, you observe that L is equal to M. That is the observed force, that is the gravity, is equal to the buoyant force. Then so the net force becomes zero, and the particle starts moving down. Reason is because of its inertia. And in such cases, we say the particle moves with constant speed, and this speed is called as the terminal velocity. If you write
Yeah.
so much, so definitely you'll get 3 marks here. Okay, is this clear?
Yeah.
Now the same question is repeated once again. Okay, what name is given to the constant speed reached by the falling bar bearing, which we have already mentioned here? It's better to mention here. And here, this is nothing but terminal velocity. Then calculate the constant speed reached by the ball bearing. Show clearly how you use the graph to work out your answer. This will be a 2-mark question. Yeah, so how do you do that? What is the terminal velocity from the graph?
It will be the slope of the graph.
Exactly. So you will first answer that terminal velocity is equal to slope of the graph, which should be equal to slope. Just don't say slope of the graph. You should just say slope AB here. You are not going to determine anywhere else. Yeah, slope AB here,
Yeah.
which should be equal to,
The change in distance by the
tell me
change
what is
in
the value?
time. So, um, uh,
What is the value?
um, 0.6 by
No,
5.
again. You have to
Yeah.
get
Okay.
me
Zero
the
point
writing here.
0.9. Zero
Is it
point 9
0.9? Yeah, 0.9, 0.9
minus 0.3.
minus 0.3 divided by,
Uh, 10 minus 5.
is it 10? See, has it gone to 10? See, 10 is
Oh,
here. Huh. Then
um,
it's
it's
only 9 here. 9 here, right?
9. Yeah.
9 minus, what is this value? It's a 5. Okay? Did you get it?
Yeah.
0.3 divided by 2, or this would be 0.15. What's the unit?
It's meters per second.
Meter per second. Okay? So you have got this here. Right. Any doubts on this so far?
No.
Okay. Now let us look at the next one. The diagram shows an athlete at the start of a race. Okay. The race is along a straight track. In the first 2 seconds, the athlete accelerates constantly and reaches a speed of 9 meters per second. So does it mean he's moving with uniform velocity or accelerated motion? What kind of motion is this?
Um,
What kind of motion is this? Is it an uniform velocity motion or an accelerated motion?
an accelerated
It's an
motion.
accelerated motion. Okay. So what is this velocity? Is it an uniform initial velocity or final velocity?
The final velocity
This is the final velocity, v equal to 9. Okay, now let us start with this. Calculate the acceleration of the athlete. Show clearly how you have worked out the answer. What is my acceleration?
it's v minus u by t.
V minus u by t. So what is v? 9.
V is
What is
9
u?
and u is 0.
U is 0. Time
2
2.
seconds.
So answer should be
4.5 meters per second
meter per second.
square.
Second square.
Yeah.
Remember this. Okay. So unit should
Yeah.
be clear. Which one of the following is a unit for acceleration?
Meters per second square.
Good. Meter per second square. Complete the following sentence. The velocity of the athlete is the dash of the athlete in a given direction.
Is the speed of the athlete in a given direction.
Is the speed of the athlete in a given direction. Okay. Then complete the graph to show how the velocity of the athlete changes during the first 2 seconds of the race. So how does it go in the first 2 seconds of the race? Let me go back to the data. In the first 2 seconds of the race. So what kind of graph is this? Velocity, this is time. So what kind of graph should I get here?
It'll be a straight line graph.
Yeah, it will be a straight line graph. Then starting from and ending at,
It starts from the origin and it ends at
it ends
two
at
seconds and 9 meters on two two on the x-axis and 9 on the
right. So two,
y-axis.
yeah, 2 on the x-axis and 9 meters on the y-axis, 9 meters per second on the y-axis, which should be somewhere over here. So therefore, I should now draw a graph like this over here. This should be the graph here. Actually, it should be here. So maybe I should draw it like this over here. It should be like this over here. Okay. Label the graph. This is OA here. Right. So this is done. And then many running shoes have a cushioning system. This reduces the impact fact on the force on the athlete as the heel of the running shoe hits the ground. Okay. When you hit it, there's an impact, okay, which has been reduced. The bar chart shows the maximum impact force for 3 different makes of the running shoes used on the 3 different types of surface. Okay, so this is a maximum impact force in newtons, and this is make A, this is make B, this is make C. You have something like Nike, Adidas, Polo, and so on. So these are the different things, and it is because of the different types of surfaces that people have used polyurethane, acrylic, and grass. Okay, this is based on the surfaces that has been used on the 3 different surfaces. And then which one of these 3 makes of running shoes A, B, or C has the best cushioning system? Which one do you think is the best one based on the histogram?
Um, oh, it's make A
Make A, why?
because it can withstand higher forces.
Yes, it can now withstand the higher forces. Okay, for lower forces it's always fine, but for higher forces your shoe should be able to withstand it. So it is A. The data needed to draw the bar graph was obtained using a robotic athlete fitted with electronic sensors. Why is this data likely to be more reliable than data obtained using human athletes? So why do you think so? Why is
Because
this going to be more reliable? Yeah.
it would be difficult to use electronic sensors on on humans.
Now, what is the question asked? Why is this data likely to be more reliable? The
Yeah,
data that a robotic athlete has done is more reliable than the human ones.
because the robotic athlete can be fitted with electronic sensors, but
Okay.
a human athlete, you could not do the same thing to a human athlete.
You can. Why not? When ECG machine and EEG machine can be fitted onto a human to determine the sensor, to determine the variations in the brain signals and so on. So why can't we do that for the electronic sensors here? You can do it.
Uh, I'm not
Now
sure.
let us consider a simple experiment. For example, you have a weighing machine, okay, which is nothing but an electronic sensor. And now what you do is you stand. I ask you to stand on the weighing machine to determine the height. So to determine the weight over here. When you are determining the weight over here, so what you do is when you stand on it, there are 2 ways of standing. One is, okay, you gently stand on top of it and wait for the meter to get calibrated properly and then indicate you what is your weight. That's one way of doing it. The other way of doing it is after you stand on top of it, you press your foot. Okay. So you give more force to this. You just press it up, down, so on. So you impress your force over here. Then what can happen? The weighing machine will definitely show you a wrong answer, right?
Yeah,
So therefore, it only depends upon you, like how much force are you going to put on the weighing machine over here. So it does not depend on any other thing. So in a similar way, when you fit your shoes with a sensor, when you fit your shoes with a sensor, and the sensors are here. So what can happen is the way how you impress, how you put your foot, or how you actually lay your foot on the ground. So correspondingly, the data is likely to change. But if the same thing is given to a robot, so what it can do is, okay, the impression what it gives you depends only on the mass of the robot, not anything else. Because robot
Yeah.
doesn't know how to increase its weight or how to increase a more force on it, right?
Yeah.
So therefore, the data that you get from here is more reliable than the one which human athletes can use it. Did you understand?
Yeah.
Right. Let us move on to the next one. The diagram shows the forces acting on a parachutist in a free fall. Okay, so object, he's a free fall, 1 year resistance is observed. The parachutist has a mass of 75 kgs. 75 kgs. Calculate the weight of the parachutist, gravitational field strength is 10 Newton per kg. Show clearly how you work out your answer and give the unit. Calculate the weight of the parachutist. Yes. So how do we do? Gravitational field is given to you. You have to find out what is the weight of the parachutist when he is falling down. What is its weight?
Um, it'll be um into 75 into 10
75 into 10, which should be 750 unit.
newtons.
Newtons. Okay. The graph shows how the vertical velocity of a parachutist changes from the moment the parachutist jumps from the aircraft until landing on the ground. Okay, so this is your velocity versus the time, right? They use the idea of forces to explain why the parachutist reach a terminal velocity and why opening the parachutist reduces the terminal velocity. Now, can you explain this question? Now, initially, what is happening in the VT graph? You see, at t equal to 0, the parachutist is now jumping from a very larger height. The velocity is very, very high. So the velocity is lower. And then the velocity keeps on increasing here. Am I right?
Yeah.
As it keeps on falling down, the velocity keeps on increasing. As time proceeds, the velocity keeps on increasing over here, though it is not increasing like this. So what is the difference between an increase in velocity like this and like this? Both are increasing only, but what is your difference between these two?
Um, it, the lower one means that the acceleration is um the acceleration is decreasing.
The acceleration here
Decreasing.
is it decreasing? Acceleration is increasing or decreasing when you have a graph like this, upwards?
Um, oh wait, no,
It's increasing.
it's increasing. Yeah.
And here, acceleration is decreasing. The rate at which the velocity increases is decreasing here. And here, the rate at which the velocity increases is increasing. Did you understand? There's a difference between rate increasing and velocity increasing. Okay.
Yeah.
So here, velocity is increasing in both the cases. But the only difference is that after how much time, let us say, for example, if I had drawn a graph like this, in this way, then you can always ask the question, in 1 second, what is the change in velocity? You'll be able to get an answer something like 20 meter per second is the change in velocity in this case. But if you ask the same question here, you can say the change in velocity is seen to be 5 meter per second. Did you understand?
Yeah.
Okay, the velocity keeps on changing, but at a constantly decreasing rates. And here it is constantly increasing rates. Okay, now let us come back to this. So a person is falling here, you get a graph like this. And now what's happening here? Why should I get a curve, or what does this denote? See, the velocity kept on increasing until this point. And after that, why does the curve flattens down?
It flattens because the a person reaches terminal velocity, the
Yeah, so
parachutist.
therefore he reaches a terminal velocity somewhere over here, from here to this point when he opens the parachute until this point. So what is the duration of his terminal velocity?
Um, it's about 10 seconds.
It's about 10 seconds or 9 seconds. Okay, so fine. So now as he is falling down 10 seconds, he is moving at the uniform speed. That's what happens. And the moment he opens the parachute, now why is this a dip here? What does it tell you?
Um, the velocity it's decelerating.
Yeah, the velocity suddenly drops down. Okay, so velocity
Yeah.
suddenly drops down from 60 meters per second to around 8 meters per second. Is this clear?
Yeah.
Okay, so now from the graph, we have understood what is the problem about. We have still not answered the problem. Now, using the idea of forces, so you should now start explaining using the idea of forces. Explain why a parachutist reaches a terminal velocity and why opening the parachute reduces the terminal velocity. Now, initially, when he is coming down, why does he reach the terminal velocity? First question. Why Vt? What is the answer? Why does he reach the terminal velocity? What is the answer?
Um, it's when the air resistance, the force of the air resistance will be equal to the force of the parachutist.
Yes, because of the force of air resistance. If the force of air resistance is equal to the force of gravity, if they balance each other, then he attains the terminal velocity. So first question is answered. Second question, why opening the parachute reduces the terminal velocity? Why Vt decreases?
Um,
Why does it decrease? Opening a parachute, why does terminal velocity decrease?
the air resistance will increase.
Yes, air resistance will increase. Or air resistance will be, can we say this is greater than mg?
Yeah.
If it is greater than mg, then it should go upwards, right?
Um,
That's what should happen, right?
well, yeah, but
Right?
it,
Hmm. But it doesn't go upwards.
yeah.
Then, so how do we reason that? I'm taking up some extra questions here, okay, which is not there in your syllabi, but to make you sure that you understand this. So F air is not greater than mg or F air is less than mg. What is happening there? Now, first of all, opening a parachute, why do you think air resistance should increase? That link is
Because
missing. Yeah.
um,
Opening a parachute. What happens when you open a parachute? Opening a parachute, what happens? This would be a 5-mark question. So you need to write in detail. Yeah. Opening a parachute, what happens?
um,
There is an increase in surface area,
yeah,
right? When there is an increase in surface area, the air resistance also increases. Okay. Definitely air resistance greater than mg, but it will take some time for it, okay, so that the air resistance and mg will be equal. So now as a result of
yeah,
it, now he already has a lot of inertia here. See, He has an inertia of around, it's a very high inertia, he has around 60 meters per second as his velocity. Though air resistance increases, it is like you are moving at a speed of 60 kilometers per hour in the highway and you suddenly apply a brake. And when you apply brakes, what happens is the backward force is much larger. Okay, but still it takes some time for you to reach a given point so that the stopping distance is already there. Right?
Yeah.
Okay, so as a result of it, the stopping distance is this. This is not the stopping distance. This is a change in velocity multiplied by time will give you the stopping distance. And then, so as a result of it, after some time at this location, now what is he asking? After a certain time, why opening the parachute reduces the terminal velocity? After opening the parachute, the terminal velocity reduces because the opening the parachute increases the surface area, which in turn increases the air resistance. And when the air resistance again becomes equal to mg, again becomes equal to mg, okay, at that point you can see the terminal velocity will be present, or you can see a terminal velocity once again. As a result of it, the terminal velocity reduces. Is this clear?
Yeah.
Okay. Then a student wrote the following hypothesis. The larger the area of a parachute, the slower a parachutist falls. To test this hypothesis, a student made 3 model parachutes A, B, and C from one large plastic bag. The student dropped each parachute from the same height and timed how the parachute took to fall the ground. The height that the student dropped the parachute from was a control variable. That means, let us say, for example, he's dropping from this height. This is my ground. So this height is always seen to be a constant. This height was seen to be a constant here. Okay. Then name one more control variable in this experiment. What is the other control variable here while we do the experiment? The larger the area of a parachute. So that means this area is larger. See here it is much larger. Then it takes a longer time. This takes much more lesser time. And this takes the shortest time interval to reach here. Who will reach first? He will reach first. He will reach second. He will reach third. This is 1. This is 2. This is 3. Now can you tell me what is
Yeah.
another control variable that I should use to do this experiment?
The mass of the modeling clay.
Mass of the modeling clay. Wow, that's great. And then any other
Um,
parameter do you think will be useful apart from mass of the modeling clay?
um,
If I
I'm
ask you
not.
to give you 2 control variables, yeah, tell me.
Uh, no, I'm not sure. That's.
What about the wind? Right, if the wind,
y-
which is due to this falling of this, if it is blowing in this direction, you do it in an outdoor environment, definitely you will get a different result, which will not be correct, right? So that also could be one of them. Then use the student's hypothesis to predict which parachute A, B, or C will hit the ground first. I already told you. Which one? I have written it there also.
Yeah, the first
First one.
C
Okay.
will reach
Yes.
first.
Right. Now let us move on to the next one. Oh, we have finished all the 6 questions over here. What is the time taken? It's 1 hour, 18 minutes. Okay. Not bad. So what I did was I just looked into your paper and then coined 6 questions to find with what speed can we do. Okay. So definitely we are going at a good speed. This was only for your first chapter. So any doubts that you have now?
Okay. No.